Okay guys, some hard-won progress. Here's these nice little axles, man. These are looking good. Really good. Use my link bender to put in nice regular bends. They're both exactly the same. Let's put them side by side so you can see how nice that is. My client is sending servo horns, aluminum clamping servo horns, so we'll be able to upgrade those pretty soon. You can see I've got everything attached with the nice stainless button heads. Going to reuse the Red Cat links. I popped in new Revo balls, the big balls, so we can use the 3mm to attach it to the chassis. So now it's just a matter of taking this nice looking piece of aluminum here and seeing if this is the right material to use for the links. This is from a different source. The last aluminum I got was from McMaster. Real hard, really nice. This is T6 6061, but I don't know if it's the same hardness as the McMaster rods or not. I'm out of that material. Cut them, bend them, put threads on them, put starter threads using tap, not all the way, just starters, just to get them going. That's what seems to work best with these. If you go all the way in and all the way out, it's a loose fit. If you just start them and make the threads bite into the plastic, it really grabs them good. And these are the Traxxas 5347 Revo large ends for 3mm. So let's get to it, man. Alright, more fun facts for link makers. If you use the Revos, okay, you've got enough space inside for 1 centimeter, 10mm of thread. That's it. So when you're checking out your link links, 1 centimeter, 10mm is going to get buried in here. Then these are overall, from the end to the eye, is about 17, okay, 17mm, okay? So what you've got to do when you're trying to figure out how long of a piece that you want is you're going to be taking 14mm off of your total length. So if you want 130, okay, you're going to go with 116, right? So if you were just making a straight 130mm length, you'd cut this to 116. You'd put 1 centimeter of thread on each end and screw in your ends, so you'd have an exact eye-to-eye length of 130mm. Where things get interesting is when you start bending things, you start losing eye-to-eye distance. If you were to make this zigzag, obviously, you'd use a lot of rod to get from here to here. Even just a gentle bend like that adds a couple millimeters, and that's really the part where you have to take some wire, make your shape, measure it, stretch the wire back out, measure that, and see just how much it grew, and then add that. Okay, so once you know what kind of bends you want, it's going to be different for every bend. For a little bend, it might just be 1 millimeter. For a big curve with another curve, you might have come in 5, 10, who knows. It really depends on your bend. So that's where I start bending wire. So to give you an example, okay, let's say I could produce this kind of a bend. Okay, I've got my wires tucked in to the ends. I'm getting eye-to-eye length of 120. Okay, but when this is straight, it's 130. Okay? When it's straight, so I'm losing 10mm approximately to my bend. So to start off with, I'm going to cut 126 lengths and thread them straight. That's how I'm going to start, because it's much easier to thread this rod when it's straight. It's much, much easier. Cut the rod to the exact length and attempt to get that bend. I'll be able to get this bend. The other bend, I'm going to have to use a vise fixture that I've made out of plastic. You can't get a little tiny bend like that right at the end without having a whole bunch of waste. So I'm going to attempt to get that nice curved bend there by chucking it into my bending jig and bending it right at the end and see what I come up with. If that works for me, then we've got an easy winner because I can use this tool to make this bend. No problem. And this wire is not ideal for this. It's too wiggly, it's too flexible, it's too lumpy and bumpy. Coat hanger would work good, but be prepared to have plenty of coat hanger and measure it beforehand and then bend it and then see the difference, because you can't unbend it very easily like this. Alright, so here's the first piece I want to test with. Okay, and what I'm going to do is try and show you by setting up over here so you can kind of watch the action in general. Okay, chuck it up in the drill, cordless drill. Put a nice chamfer on it. Over to the vise here, so you can see what I'm doing with that. Before we get going, I just wanted to show you the kind of die you want. You want a threading die with a little screw that'll spread it. Use a little screwdriver and you spread it. Put it in your die holder. And that's, so you start with it open to get nice, easy to get threads. You go on down it, and then you go again after you've slacked off the screw. And then you put sharper threads on it. So it's a two-stage process. Okay, so when you're looking at your die, you're going to see one end that's more open and one end that's more closed. And you want to start with the open end, obviously. You want to have your little screw spreading it. You want to have these screws holding it in the die holder. And then you just push your thumb down on it in the center. And I start dry. My tap is pretty oily already. Uh-oh. My die holder let the die spin around. I must not have it in exactly the right place. Let's see what's going on. Yeah. You got to get it right in these little detents, or it will get away from you. I thought I had it right. I did not have it right. There we go. That ought to be right. Yeah, okay, yeah, you can feel it. It'll rotate a little bit as it locks in. Okay, now I got it. Alright. This is what's backing up the die, keeping it from just popping out. Alright. Boy, a lot of gyrating. Trying not to block the view of what's happening here. What you do is you go around. I do go around. My thumb's right on the center of it. I can really feel if it's going down straight or not. And once you've got your thread started, you got to come back and break the shavings off. You're shaving little spirals of aluminum off of there. And you got to snap them off. If you do a bunch of these, pretty soon you're going to get a real good idea of when you've gotten 10 millimeters threaded. But if you haven't done a whole bunch of these, you might want to either put a mark, just take the die off and measure, get an idea of what's going on so that you don't overdo it. Now at this point I can feel it getting a little sticky, and that's a good time to put some oil on it. Some oil down into the cutter. A little oil bottle. Now it's not so sticky. It's good. Now we're back to cutting threads again. I think I've got about 2 more millimeters to go. At 10. I won't overdo it. It's easier just to put it back on and put a few more threads. So I don't want to be lazy. Okay. And to keep the thing from flopping on the floor. Okay. So now you can take a look at my wood. And I grab the digital calipers. We'll get a look on this thing. and we'll see where I'm at in terms of okay, so from the very end to the threads I'm at 10.11, so I'm pretty good at guessing. You know, I'm at 9.62, 9.88. So I don't think I want to put any more thread on that. I can always add 0.3 millimeter. 9.7, right? So now what I want to do is do it again. In putting some threads on this, on these Revo ends, I got 2 of them here clamped in the vise. There's really nothing to it. What I like is I like the clutch on really low, and I just run them in. I just get a little starter thread like that. Just to get something for them to bite. I won't go all the way. This is a starter tap. Kind of makes like a cone shape. Try not to leave too much swarf in there. Okay. Theoretically, that will thread onto the end. You know, gotta hope. I took my little rod holding fixture and I just put a notch in it so I could crank that on there, and it worked great. So I'm going to be using that from now on. That was a cool little invention. So here it is. Alright. We should read 140. That's what it should read. If I made it right, huh? Lock my calipers. Spread them out one-handed to about 140. And lock it down and see if I'm right. Okay. So now we've got, I'm a touch, yeah, I'm right on it. 140, okay, good. Let's give it a bend. The reason I had the end on it was so I could have a registration point, something where I could see it. Also I can get the orientation of it right with everything nice and tight. So what I've done is I've got this eye perfectly vertical. I've got it pulled until it touches the guide wheel. So when I do the other one, it'll be the same. Whether or not it does a beautiful bend, we'll just have to see. This might be a throwaway link. Oh yeah, this aluminum's nice and hard. Good. That's what I was hoping. So what I'm looking at is a bend. This is where it'd be nice to know exactly where to stop with it. What I could do is I can measure how far apart the handles are and get that number and try and recreate it. Now I don't know if that's enough. It's not really a whole lot of bend. I think before I had too much bend. So right now I'm at 118. Let's see what happens if I come up to, it springs back. So let's see, now I'm at 119. Let's do a little more. Springs back. Now I'm at 114. A little more. Springs back. Now I'm at 110. Pretty radical bend. Let's try 100. Sprung back to 103. Probably going to do a little more than I want. Yeah, it seems to go in increments, like it goes right. So now I want to look and see, did everything stay in plane? Yeah, pretty much. Okay, cool. It would be awesome if I could now put this in here like this and get the little bend that I want right there. But you can see I would need a whole lot more rod. Then I'd have to cut it, and who knows what happens if I get what I want or not. The radius of this bend is a lot smaller than what I was really looking for. I was looking for more of a big curved radius, which is why I bent my link bender with stuff like this as a mandrel, so that it would make a big sweep bend. But I still think that's going to be a really awesome bend. Now, what I need to do is unthread this end. Woohoo, that baby's on there. Okay, and I've got a special bending fixture, which I'll show you in just a second. Alright, so here's the little bending jig, 3/16 inch hole with a chamfered cone shape in it. Okay, and let's see how this works out for me. Okay, so what I'm going to do, get it in the vise so that it won't rotate, and really clamp it down good, super strong. Okay, and eyeballing this, make sure that this is perfectly aligned with the gap of the vise. Just a little tiny bit off. Okay, now that I've got that perfectly aligned with the vise, when I pull back, all I got to do is use my vise as a sight. Make sure everything's locked down so nothing starts rotating on me, doing anything annoying. And then I just want to bend it back till this is almost perfectly vertical. So that's what we'll do. Come straight back till that's about vertical. Okay, now I've got this level here, so I can put my square right up against this and eyeball it. Tiny amount more I have to go. It springs back, so you have to kind of play with each metal that you're working with and figure it out as you go. Once again, I want to make sure I'm perfectly in plane here. I'll just pull it back a little bit. Another good look at it. Okay, now I am where I want to be. So, by doing the exact same thing again, marking everything again, in the same place again, I will be able to create two identical links like this. Just a little gentle manipulation, got the link to lay perfectly flat, which is ideal. So, I'm going to attempt to show you something here. So here I am at next to the last hole for that. Here I am at this lower shock point, as if this shock were going to mount to the axle, and that's what I'm ending up with, just like that. And if I had a prehensile tail to hold the camera, I could manipulate this and show you how wonderful this looks. I don't know if I can do this. I'm going to try and hold it down with my elbow. There we go. Ah! As good as I could do without having a tail. One little thing I skipped. I didn't, you know, I knew that the other links were 140, but we never actually looked to see what size these babies were at the one I made. And it's 130 on the nose. It's dead on 130. So the little wire guesstimating thing was close enough for what we had to do. And here's one here. This should be 140. Let's go ahead and pull this thing open. It's so much fun. Everything's getting covered with oil and it's getting nasty. So here's about 140. So let's see if that's right. Yes. Yeah. So let's go ahead and bend this one up. What the heck? I'll let you watch again. Why not? It was so much fun the last time. So I've got the system down now. So I just know that I get it in there. I get it lined up just the way I want. I push it up to the stop, and then I'm going to bring it to 100 between the grips here. So let's get a bend on it. Oh, it really moved up, man. It's moving up on me. I wonder if the other one moved up and now I screwed everything up by pinching that thing up. I bet it did. So, we are not at 100 yet. We're at the same as before. So, we've got that bend. I can check and see if I got that in about the right place. Yeah. Okay. So, now we just got to take the end off and do the other thing. Okay, just want to show you. Was able to replicate the bend. So, no biggie there. If I want to change the bend, now I know what to do. Alright. This is dead sexy, man. I was thinking to use spacers down here, but these shocks are so big around down here that's not going to work out, but they do mount straight up, and there's no problem. At least I don't see one yet. If I do, I'll go to the axle tabs, but it looks to me like it articulates without doing anything to the motor wires. This is so fun. You see just how cool that is. Big and squishy. Big and squishy. Not getting any chassis bind on the links. Not getting any cut bind on anything. Oh my gosh, that is so cool. Well guys, in my usual manner, I went well beyond what I said I was going to do. I designed and fabricated a custom chassis, and everything that all the numbers that I was looking for on paper show up in real life. Everything, ride height, articulation, everything that I was looking for, I got. And the shocks have so much adjustability, it's just wonderful. With them all the way topped out, the collars all the way at the top, you get this nice, limber, low ride height. I think that'll work out super good on the rocks. Then you just dial these down. I'm not going to bother to do that, but just imagine. And it jacks it right up, makes it a lot taller all the time. And you get ridiculous amounts of travel. More than what I get, more than what the stock Redcat gets for sure. Full up, you're at 100. All the way down, probably something like 25 millimeters. Okay, got the 120 millimeter Venom shocks, custom bent links. Okay, clear the motor really nice, just right exactly where they should be. Really happy with that. Those came out perfect. These are exactly like I wanted. You just come straight up and lets it get all over the place. It's got 9.5 inches of articulation on either end. Okay. Got about 8 millimeters of clearance, maybe, depends on how the tire's flexing, and the other tires are going to be pretty close to the same width, maybe just a tad narrower. So these are the axle wideners. I had to mod the hexes to fit. Very nice. I did my uplink mod. Really sweet bends. Does exactly the right thing. Gets out of the way. Got the horn up. Clear all the rocks. Axles packed with thread and tacky to make them watertight. Waterproof servo. You can see that there's no link bind anywhere under any condition, no matter how much it flexes. The links do not touch the chassis. They don't touch the shock. Shock nests right in there just perfectly, like I hoped it would. I mean, just perfectly. Just no clearance at all. You could just maybe slip a hair in there. I love these big slinky red shocks. They're just so cool. No clearance issues with the wiring on the motor. Okay. You couldn't slip a red hair in between it. But it's nothing that's going to cause any damage to the wiring as it operates. This chassis is the Regent 120U. for these kind of 120 millimeter shocks. That's why it's sort of tall, to make up for all that, and to have this nice parallel linkage. If you watch as this goes up and down, the axle is not clocking in a wild manner. Okay, very nice. Stays right wherever you set it. You can clock the axle back. You can make longer links, clock the axle forward. If you pull this back couple, it clocks the axle forward. But you could accommodate that by bringing this back. So you have full range of adjustability in terms of how you want to clock your axle and in how you want to shrink your wheelbase. Wheelbase, I have a long enough ruler, but we will get a pretty good idea. If we go from center to center, you're looking at, if this is the center over here, and then it comes right to the bead lock, and then to the center, and there is about another 3/4 of an inch. So we're looking at a 12 3/4 wheelbase because I have this spaced to the furthest chassis points. Now you shrink that in, and you get within full extension. You see the wheels do move back and forth, up and down, but then not radically. So right there, at full down, probably talking 13. And you can bring this in, change that. These are 130 eye to eye, have an equidistant front and back. Shocks are mounted at exactly the same points, front and back. They have an almost ideal angle to them. This is 45 degrees. You can see the parallel of that. Obviously, as you go down, that angle becomes longer, which is perfect for the kind of articulation I was looking for. And that's all stuff that I worked out on paper before I drew up the chassis so that I could get exactly what I wanted, and I got it. Very happy for my client. Now, instead of cloning my build, I want to clone his build. I'm absolutely serious. I want to replicate this for myself. Although I like my setup and I think the whole deal is great, I want to do everything I've done here, but for 100 millimeter shocks. Hey, I brought the baby up to the house to put it beside mine and have a look. And if you look at the links are better on this one. I like that straight up link better than my bent link. And I got the little S bend back further. See how far forward mine is? See how this is tighter up to the motor. That's exactly what I was looking for. Try and get it further back. You can see a lot of the similarities. Front links and back links bent up like that. But you can see these uppers are more parallel. The uppers are more pinched. Got a lot of the same ride characteristic if you just look at them side by side. You get this one up a little more in the back just by pulling the shock up. You can pull this back, lay this back a little bit. You could even dump it all the way up there if you really wanted some stink bug stands. It's got some nice adjustability to it, but I think this is the ideal ride right there. You can see how low it goes. Mine does not do that. Mine will not go that low because the shocks are just not long enough for that kind of travel. These super long shocks allow for so much more travel. all the way up. And both of them, it's the same. Once this gets the big tires, it'll be the same as that. It looks a little lower now just because of the smaller diameter tires. So once it has the bigger diameter tires, you can see that the wheelbase is almost identical on the two of them. Different chassis, different shocks, different shock mounting point. Got my shocks mounted way up there, 15 millimeters higher. Got 100 millimeter shocks versus 120s, but very close to the same mounting height because of the little axle plate. This direct mount is much cleaner, much neater looking, probably also stronger. This looks just more pro. Tabs are okay. I really like that straight up to the axle mount, which is possible because of these wheel wideners. That's the one place where there's a big difference. This way. You can see that the other one's wider. About an inch wider, which is perfect. And my tires right in the shock. My tires go right up in the shock. Boink. These tires, and then get close. Perfect. Alright, sorry about the dark lighting. Been working all day. Get to this point. Very happy for my client. I was also very happy to have a chance to learn so much about chassis design and link design and all of that. It's just been a real interesting education, practical education. Thanks for watching, guys. More on this another day.